Good afternoon, all my dear students. So only two students are present here. What about others? Is it they are attending or what else? Okay, due to less students, just we have to wait for 5 minutes that them join. Okay, dear students, let them join. Good afternoon, all dear students. Uh, am I audible? And my screen is visible to you?
Yes, sir.
Yes, sir.
Okay, okay. So only less students are there, but you tell them to join everyone. Okay. First of all, only 15 members out of 15 members, half of the strength. It's not good. Okay, anyhow, our duty we have to do it. So yesterday's lecture, I was taught already. I was taught third unit, that is assembler instruction format, machine languages. Okay. So in that we studied that label, mnemonics, operand, and commands in the yesterday's class, and with the examples and different types of addressing modes with examples and that one format, and we studied also that data transfer instructions. We studied in that data transfer instructions 12 instructions we studied. 10 are directly data transfer, and 2 are that is in and out, are input and output data transfer instructions. All these clear explanations we studied yesterday, and clear notes also with you. I think everyone is got the notes. So this one, input and output, two more we have to study. Total 12 data transfer instructions. After that also we have studied program and execution and transfer instructions. Mainly there are near and for branch. So in that we studied condition unconditional jump statement and conditional jump statement. In the unconditional we studied inter-segment indirect, inter-segment direct, inter-segment indirect, and inter-segment direct. Okay. And in that second category we studied conditional jump. These are the different categories. Just jump on carry, jump on no carry, jump on equal or jump on zero, jump on non-equal or jump on zero, jump on parity, parity and equal, jump on non-parity, and parity and odd. Okay, and also jump on below, jump on above, and above or equal, below or equal. So these we studied. Jump on overflow, jump on no overflow, jump on sign, jump on no sign, jump on less, jump on greater, greater than or equal, less than or equal. And in the third categories, we studied unconditional call. In that again, two types, intersegment and intersegment. Okay, these are the things we studied, and we studied as a return statement for the branching line and intersegment return. These much we have to studied in yesterday. So just for I will ask, how was the notes and is there any doubts with you? Please let me know any doubts before starting up my next topic today's. Okay, okay. Anyhow, today we got only 1 hour lecture. So in that I have to take the next topic, that is processor control instructions. Processor control instructions, or we say machine control instructions. Processor control instructions, or we say machine control instructions. So in this, we are going to study push F, pop F. So push F means push flag, pop flag, LEHF, SAHF, STC, ECLC, CMC, STD, CLD, STI, CLI. These are processor control instructions. So one by one, how many? 3 plus 3, 6 plus 3, 9 plus 2, 11 instructions are comes in the processor control or machine control instructions. Okay. So here the first one, I'll take it as a STC. This one. STC means what? This is an instruction sets the carry flag. Sets the carry flag if no other flags are affected. We are going to set the carry flag if no other means remaining nine out of nine, eight flags. Remaining eight flags are not yet affected. For that we are using STC. For that we are using STC. Next one is CLC. CLC means what? It is a clears the carry flag. So CLC means this instruction clears the carry flag. No other flags are get affected. So STC, CLC, these are working with do not get any affected with other flags present in microprocessor. And the third one next is CMC. The CMC means what? This is the instruction components the carry flag. Sorry, complements the carry flag. Complements means what? Reverse, either zero, it transfer to one, or one, it converted into zero. So this instruction complements the carry flag and no other flags are get affected. That is CMC. And in the next category, that is for interrupt enable flag. These two are interrupt enable flags. Okay. STI and CLI. STI means what? Set the interrupt flag. S means set, ST means set, I means interrupt. Set the interrupt flag and no other flags are get affected. Only interrupt flag is going to be set, and here C means only complement flag is going to set, and CLC means only carry flag is going to set, and STC means only sets the carry flag. Sets the carry flag. CLC means clears the carry flag. So here STI means that is instruction set the interrupt enable flag and no other flags are affected. Next one is CLI. In this instruction, it can clears the interrupt. CLI means clears the interrupt. STI means set the interrupt flag. The number of other flags are affected. Number of other flags are affected. And here for direction flag, that is STD, CLD. In the list, whatever I have to beat it as. STD and CLD are direction flag. So here in the STD, the instruction sets the direction flag that is related to the direction flag, and CLD means that clears the direction flag. Wherever CL comes, it meaning is that to clears the particular flag. If D means direction flag, if I means interrupt flag, if C means carry flag, like that. Okay. So and in the fourth category, to set the TF. TF means what? That is territory flag. So in this push up, push the contents of the flag register on a stack and pop BX, pop contents of the flag register from stack to BX, and or BH01H sets the corresponding to territory flag, trap flag in the BH register. So here to push the BX, that finally the push is modified as a BX register on the stack, and the pop F pop the modified contents into the flag register. So this is the TF, that is trap flag. And next one is reset TF, means to reset the trap flag. First one is set the trap flag, and the next one is to reset the trap flag. So in the reset trap flag, it can pushes, it is a reverse again, pushes the contents of the flag register on the stack, reverse, reset, and pop the BX. In that, the contents of the flag register from stack top to BX, and the BH and FEH that resets the corresponding to trap flag in a BH register, and push BX, that is the modified BX register into stack, and pop flag, that is uh, pop the modified contents into the flag register. Whatever we are going to set with the trap flag, that is reset by trap. So we have to use to reset TF or to set TF. Okay. So next is comes under iteration control instructions. So in this chapter, just we are going to cover only instructions only. What are the instructions are coming under microprocessor 8286? So next, I will move upon iteration control instructions. So in the iteration control, iteration means what? That is a looping. Looping means loophole. Number of cycles is going to be executed within a loop until to get the last point, end point. To reach at end point, that cycle is going to be executed. So those kind of instructions we called iteration control instructions. So these instructions pass a series of instruction to be executed repeatedly. Executed repeatedly means in cyclically to meet end condition. Up to meet end condition, the cyclically it is going to be executed. That one, the instruction calls series of instruction to be executed repeatedly. So the number of iterations is loaded in CX register. X means either higher or lower level for the 16-bit CX register. So that CX register is decremented by 1 after every iteration. Why it is decremented 1 on every after iteration? It means that one cycle is completed, then one decrement is happened. For that, it is decremented by 1 after every iteration to cause until CX is becomes to meet last condition means 0th condition. Okay. So the maximum difference between the address of the instruction and the address of jump can be a total number of 127, 127 number in the iteration for maximum difference with the address of the instruction. Okay. So this is the iteration instruction. In that, first one is a loop level. So in the programming, we are using loop. So loop level means it is jumps to specified level where the controller is moved to go to a particular line for the execution of program code that is equal to 0 and decrement by CX, because CX is finally we have to make it 0 until and unless to meet end condition, that is CX is 0. For example, if CX is having a 0 4 value, so that back here you have to take back, and you this one we call it as a label also as per our mnemonics format. This one is a label, is nothing but back. So that back we are going to connect it with here. Actually, the loop is happened back. So the controller is again comes to this point, again executed number of iteration times. Number of times it has to be iteration up to reach end meet condition. Okay. So in that move AL comma BL, add AL BL. It is going to be add to meet the last condition. For that to repetition of execution this code, we have to use the looping concept. That is nothing but loop label. This is the label as you studied in the first format. Okay. Back, and here this is the back. That connection is going to here. So this entire times n times means number of requirement of iteration is going to be executed in the loop label. Okay. So next one is loop equal or loop on 0. So LWOPE, loop on equal or loop on 0 label. So in this, the sum as above expectation that looping occurs only if the 0 flag is set to 1. Otherwise, it is loop on 0 should be happened. Okay. So here back, one example, same example you have to follow with BL and EL. So it is only different. How it is different with the loop label? Either it may be equal or it may be 0. Again, the loop is going to be happened, and n number of iteration is going to be execution of this code. That is loop equal or loop on 0. So in that next third one, loop on not equal or loop on non-zero. Loop on not equal. NE means not equal. NZ means non-zero. That is loop on not equal. Loop on no zero. So here it is same as above, but looping occurs only if zero flag is reset to zero. Zero flag is going to be reset. It means that the ZF flag is 0. For example, move CX1 register with the 4 value, and that back is move AL, BL, and add the AL and BL, whatever the containing. Finally, move BL comma AL. Again, the AL register is transported into BL. So again, loop on non-zero. If non-zero occurs, then it comes back to move AL comma BL. Again, the iteration is going to be repeated. So n number of times again it is going to be executed of this code. Okay. So this is the three main categories in the iteration. That is iteration control instructions. So loop label, loop equal or loop on 0, loop on non-equal or loop on non-zero. Okay. So this is the iteration looping statement. Now I'll go to next category, that is these are shift and rotate instructions. So in the shift and rotate instruction, there are either right shift or left shift in the shift, and rotate also either right rotate or left rotate. So shift means SHL, shift left or shift right. SER means SHR means shift right, or SER means shift right with carry, shift left with carry. So here, and rotate left, rotate right, rotate left with carry, and rotate right with carry. So in the 4 category of shift and 4 category of rotate, totally 8 shift and rotate instructions are there. 4 for shift instruction and 4 for rotate instructions. So first I will move to shift and rotate instruction. SAL, SHL. It means that it is using one destination and one count. So for SAL means what? That is shift arithmetic left. SAL means shift arithmetic left. SHL means shift left. Okay. SHL means just shift left. SEAL means shift arithmetic left. For example, left shifts to the bits of the destination so that MSB shifted into the carry and the LSB goes to a place of 0. So the bits are shifted count number of times, and if the count is equal to 1, it is directly specified in the instruction. Otherwise, the count is greater than 1, it has to be given using CL register. Okay. So for that, the destination register memory location, for example, SKL BL comma 1, it means that left shift of BL bits. If BL bits is 001, then 1 bit is going to be shifted left. 0010 it becomes. So here one example I have to give one, consider BL equal to 001 in this example and 110. So what it will do, and the carry flag is 1. So how it is going to be shifted? That shifted is 1 is carry, 001 as this number 11, and add this number 1100. So it is going to be shifted here. 0 is comes, uh, this 0 is comes to this position, and this 0 is comes to first position. 1, second, third, fourth, fifth. So one bit is shifted, and finally the last bit is vacant. That is filled by 0. That is filled by 0 because carry flag is 0. If carry flag is 1, it is going to be filled by 1. Okay. So this is the right shift. So yes, this is left shift. SKL, left shift. Okay. So next one is SHR, right shift. So here also we have to use one count and one destination with a shift right. For that, it shifts the bits of destination. MSB gets 0 and LSB shifted into the carry. So the bits are shifted count number of times, and that is count is equal to 1. Then it is directly specified in the instruction. If count is greater than 1, then it has to be given using CL register. So that shift right BL1, it means that, for example, 0011 and 001 example. So that same value formats I have to show 001 1100. So here the carry is 0 and it is going to be shifted 1 to here, that in the example, and this 1 to here. So 00 again 00, 1111, and these two 0, these two 0 shifted here, and finally that is added by last second bit is 0. That is 011 100. It becomes after shifting left 1 times. No, after shifting right 1 times. SAR. Okay. And next one is SAR. So it means that destination and count. It is an arithmetic rotate, arithmetic shift right. Shift arithmetic right. SKR means. So here in this example, for the count 1 and count is greater than 1. So in this example, 0011, 0011. So that is, I have to make it here 0011, 0011. And how it is going to be shifted with arithmetically? Each bit is, this bit shift to here, this is here, here, and here. So finally that last bit is filled by 0th value. So as I showed here, 0th value. 0011, 0011 is here, and 0011, 001, and first one is shifted to here, and at the second place that is filled by 0th value. Okay. So this is shift arithmetic right. Next one, these are the shift register, shift arithmetic right, shift arithmetic left, and shift right. So shift left. Okay, shift arithmetic left and shift arithmetic shift left, shift arithmetic right, and shift arithmetic right. Okay, totally 4 shift registers control instructions. Next one, I'll move to rotate instructions. So these are the rotate instruction. First one is ROL destination count. So here the left shifts of the bits of destination is going to be shifted at left, and the most significant bit shifted into the carry flag. Also, most significant bit goes to LSB. So here in this you have to see the example for if generally I have to show this is the carry flag. Carry is occurred here, and total destination, that is the 8 bits D0 to D7. So if this carry flag, this D7 is directly shifted back to its end, back end, means that one rotation is happened each time, one rotation. So move CL05, it means that ROL rotate left. BL comma CL means BL and CL are going to be rotated left by one digit each time. That is rotate left. So here again, D7 to D6, and this D0 is shifted to here at the D7 position. That is rotation should be happened continuously, should be happened. That is rotate the destination. Okay. So next one, RCL destination count. It means that rotate left with carry. Rotate left with carry, or we say rotate carry left. So in this instruction, again we are using one destination and one count. So for that, the left shifts the bits of destination, and the most significant is again goes to with the carry. So the bits are shifted count number of times. So the count is equal to 1 and count is greater than 1. That time we have to shift it. This D0 is directly with the carry. Previous we are connected to here only at the D7 positions. But in this with the carry only it is going to be shifted. Same way RCR, that is destination count. So in the destination count, the rotate carry right. So here the right shifts the destination bits. So the least significant shifted into the carry, and it goes to most significant. So this is the least significant, and this is the most significant. Least significant to most significant rotation, opposite of RCL. So here that is most significant to least significant. In the RCL, rotate with carry to the left, but rotate with carry to the right. That is least significant to most significant rotation is happened. So these are the rotate, shift and rotate instructions. For the shift instructions, 4 are there, and the rotate instructions 4 are there. So by knowing this is complicated, but whenever you have to use with the program, so tomorrow you have a lab session at for 3 to 4:30, right? Okay, 3 to 4:30 tomorrow you have a lab session. That time I will execute this kind of program. That time we have to more clear with the programming concept. Okay. So dear students, just I have to taught 8 instructions of shift and rotate for each, and 3 instructions for iteration statements, loop label, loop on equivalent 0, and loop on non-equivalent 0. So 8 plus 3, 11 instructions, and I have to use it again 5 trap flags, that is trap flag and STD, CLD. So totally today 16 instructions I taught. So what you will know, just you go through these 16 instructions. Okay. Next, we will start with next kind of instructions after shift and rotate. After shift and rotate, there is some kind of interrupt control instructions. Interrupt control. Interrupt means what? There is a sub abnormality during the execution of microprocessor program. We are going to handle those kind of abnormality. For that, we have to use some kind of instructions. So that is, we are going to see the instruction. So here, so don't worry, all the instructions, whatever I have to taught at the end of this class, I will be list out it and I will transfer you each and every instructions. Okay. So this is for today's what I taught, 15 instructions with you. Very easy, just one or two lines, just to come to know. Whenever we are using all these instructions for the execution of microprocessor program, that time you may understand it clearly, and you may get to know that what is the purpose of particular instructions and why we have to use it and how we have to use it and what purpose we have to use. Okay, so this is all the things we will look into that in the program sessions. So after that, there is a interrupt control instructions. So in the interrupt control instructions, that is int type. First one is int type, int interrupt on overflow, that return from ISR, interrupt service routine, that is pop, pop CS and pop. So again, three are interrupt control instructions. So as I said, interrupt means sub abnormalities during the program executions. Okay. So in that again there are three category: int type and interrupt on overflow. INTO means interrupt on overflow, and IRET means return from ISR. Okay. So these three instructions, just we will look into that. In this instruction, it causes an interrupt of given type. So the type can be number between 0 to 255. It means total 256 interrupts. That is going to be handled by int type of instructions. That is int type of instructions. So in this, all these interrupt instructions we use it for push handling, pop handling, and that we are instruction pointer, code segment into the stack, decremented, incremented purpose. We have to use this int type of instructions. And for this int interrupt overflow, int O means interrupt on overflow. This instruction causes an interrupt of type 4 only if overflow flag is set. Only if the overflow flag is set and the above sequence is followed and control is transferred to the location pointed by 001H. So any one of the location is pointed by 01. So in that time the interrupt is occurred, that INTO is going to be handled. So that purpose we are used this instruction INTO. And in the interrupt, there is a third category, that is return interrupt, interrupt return, or we say return from interrupt service routine. Under this, there are three categories: pop IP, pop CF, pop flag register. Pop IP means that is pop of instruction pointer, pop of code segment, and pop with the flag register. So from that stack, we are going to be decremented, use the instruction pointer, and along with the code segment or stack segment, we have to use the stack pointer decremented by two numbers. Okay, and the flag register from the stack and the stack pointer decremented by 2 is going to be happen in the IRET, that is return from ISR, interrupt service routine. Okay, so again these three. So totally today 18 to 20 instructions I have to taught, and all clear notes I given to you. So what you will do now, just you go through today's instructions, whatever I covered up to interrupt control instructions. Okay, so after that we will move to string instructions once we perfect on these. So I'll give you 10-minute time, 10 or 15-minute time. So 15 to 20 instructions I taught. Take 20-minute time to read it one by one, all the instruction. So you will get to know clear understand. Okay. So one by one, you have to understood. But you, whenever and up to you will not done the programming. So in the programming lab session, you have to understood all these instructions. Just this is a theory part. Before starting directly a program, just I given you a theory part. So in that, just you come to know this particular instruction is used for what. So 20 instructions I have to cover today. So please all of you go with 20 instructions for 20 minutes. So these 20 minutes you have to start to read with these instructions, whatever I covered today up to. So here I'll show that point, that is okay, iteration control, yeah, processor control machine instructions. From today I have to start it. That is page number 17. Page number 17 to page number 25. I think so, or page number, yes, 25. Page number 17 to page number 25. Please go through it. 20 instructions I have to cover. Just you have to read it out for this 20 minutes. Okay. Yes, fine. So while going to study, if any doubt also you have to let me and get the clarified of your all doubts. Hello. Okay. Okay, dear students. Please go through the notes again. So read it well. All the instructions. Near about 20 instructions I have to cover today. So please go through it. And if anything else, please let me know in the free time. Message me, WhatsApp me, text me, mail me, call me for your any you facing the problems with this. Okay. So I'll stop it here. So because next one more lecture I am going to handle for the regular batch. Thank you all. Now you can log out.